Hey everyone, welcome to Math 104, sections 4.3 and 4.4, Introduction to Polynomials. So in business, a revenue is a company's income. It's like a paycheck for the company. And businesses have bills to pay too. We call those expenses or costs. And when you subtract costs from revenue, you get profit. But what if each of these variables isn't just a number? What if it's an entire equation? For that, we need function notation, and that's where we're going to start today. So function notation, it's a way to give a name to an equation so that we can refer to it without having to write out the whole equation. So mathematicians, they love shorthand. So function notation is structured like this. We got the function name, some letter, usually F, G, or H, and then you got parentheses with a variable inside it. That variable is the input, and that variable is what will appear over here in the equation. If we have an x here, we're going to have x's in the equation over here. We could have x's and y's here, and that would mean we have an equation with x's and y's in it. So basically, what's in the parentheses declares what kind of variables you're going to see over in the equation. And this is the input value. Functions have input and output. We input a number, we get out another number. Now this is read f of x. Keep in mind this is not multiplication. Usually when we see something outside of parentheses, it's implied that there's multiplication there. It's not what this is. This is function notation. It's totally different. It's just declaring that we have a function. Okay, and it's read f of x. Now let's talk about input values. We can input numbers into the function. So if we want to input 3 into this function, we write it as f with 3 in parentheses. And this is read f of 3. So then we take that 3 and we plug it in, and everywhere we see an x, we plug in an x. So in this case, we get 2 times 3 or 6. So f of 3 equals 6. And from this we get an ordered pair. And an ordered pair is a set of coordinates. So x goes in the first position, and f of x goes in the second position. So whatever we're inputting into the function goes here. All right, that's the 3, that's the input. And whatever we get out of the function goes here. So this part of the equation, this just tells what the function does. So that you could describe this as being a doubling function. Every value that we plug in here, we're going to multiply by 2, so we double it. First example, we've got f of x defined to be 2x squared minus 4x plus 7. And we want to find f of negative 3. So we're going to take this negative 3 and plug it in for every x. So we get 2 times negative 3 squared minus 4 times negative 3 plus 7. And that gives us 2 times 9 minus negative 12 plus 7. Or 37. Now, we've got an ordered pair then. And the ordered pair is negative 3 is the first number. Remember, ordered means we have to get these in the right order. So negative 3 is the input, the output is 37, so 37 goes in the second position. That's f of x. Your turn, number 1. Let f of x equal 3x squared plus 2x minus 15. We're going to find f of 2 and the ordered pair. So we get 1 out. So f of 2 equals 1. And the ordered pair is 2, 1. 2 is the input, 1 is the output. So the collection of all these ordered pairs make up the graph. So if we had a graph of f of x equals 2x, the point 36 would be right on that line. Now, a polynomial is a specific type of function with terms in a specific format. All the terms have this format: some number times x to the nth power, where n is some integer. Actually, n is some natural number. All right, so we're not going to have any negatives, only positive values for n, and only whole numbers. So some examples of polynomials, we got things like 3x squared minus 7. So you may have a string of these, and they all have a different exponent on the on the x. So here we got 3x squared, and we can have constants. It's okay to have 7 there, because you can consider 7 to be 7 times x to the 0 power. Anything to the 0 power is 1, so that's still 7. We don't write that part. So all the terms have this kind of a format. Now the numbers, the coefficients, those can be anything, any real number. So you might have something like pi x squared minus the square root of 2x. That's fine. You can have irrational numbers out in front, no problem. But where you can't have them is we couldn't have something like 2x to the pi, because pi is not a whole number. So we can't have any irrational numbers up there. We can't have any roots as the exponent. Like 3x to the square root of 2, can't have stuff like that. Those are not polynomials. Also, any kind of square root, as we'll see later on in the class, you can rewrite this as x to the 1/2 power. And so that's not a whole number, so that's not allowed. We also have any kind of negative exponent, like this next example, 1 over x, which can be written as x to the -1. So we can't have any variables in the denominator. That's not a polynomial. And any other negative exponents, higher negative exponents, like the next example, 4x squared, or 4x to the -2, can't have anything like that. Now we're going to have to be able to classify polynomials. And we classify them by the number of terms. If you have one term, it's a monomial. Now look at the prefix. We have mono. Mono means one. And this prefix is found, especially in the sciences, it's used quite a bit. Monoculture from biology. Mononucleosis, it's something with a single nucleus. Monoamine, it's a chemical structure with a single amine in it. So, monomial, one term. Binomial, bi means two. Think of a bicycle, bifocals, things like that. Number of terms is 2. Trinomial has 3 terms. So think of triangle or triathlon. It's where you do swimming, running, and biking all in one event. So, and you can see some examples of those. Remember, the terms of things are separated by plus or minus. Now the degree of a term is going to be the exponent of the variable if we have a single term. Degree. All right, so we're going to find the degree of these monomials. So to find the degree, we just look at the exponent on the variable. So this is degree 6. Now if you have more than one variable, you have to add up the exponents. So we got 2 and 3, we're going to add those together to get 5. So this is a degree 5 monomial. And this one, just like we saw over here, we can always add on an x to the 0. Well, that's what we'll do here. That's the exact same thing. 2 and 2x to the 0 power, they mean exactly the same thing because x to the 0 is 1. And 2 times 1 is 2. So you can think of any constant as being degree 0. Your turn number 2. Determine the degree of those two monomials. So for the first one, we have just one variable, so the exponent is the degree, so we have degree 3. And this one, we're going to add up all the exponents. We got 4, 2, and the implied 1 here. So 4 plus 2 plus 1 is 7. That's degree 7 monomial. Now, the degree of the polynomial is the greatest degree of all the terms. So you find the degree individually of every term and just select the highest one. So for example, we've got, and we're going to classify this polynomial and state its degree. So we're going to tell what type it is and the degree. So 9 minus 5x plus 12x to the 4th. All right, so the degree of the terms, degree 0, degree 1, and degree 4. The highest one is 4, so this is a degree 4 polynomial. And it has 1, 2, 3 terms, so this is a degree 3, or degree 4, trinomial. I go ahead and classify the two polynomials in your turn number 3. All right, first one, we've got degree 2 here and degree 0. Highest one is 2, so that part A is a degree 2 binomial. Binomial because it has 2 terms. And for B, this would be x to the 0 power. Any constant is a degree 0. It has 1 term, so it is a monomial. So polynomials are generally written in a certain format. It can be very confusing if you just write whatever term in whatever order you feel like. And it's a lot harder to figure out the degree. So we write things in descending order so we can immediately see the degree and the leading coefficient, which are important for analyzing the behavior of polynomials. So leading coefficient is the coefficient on the term with the highest degree. And if you write in descending powers, it's the first number you see. So we're going to write this polynomial, 3x squared minus 4x plus 5x to the 3rd plus 9. We're going to write this in descending powers and find the leading coefficient and the degree. No, we're not finding the degree, just the leading coefficient. Okay, so we're going to find the exponent, highest exponent, 5x to the 3rd, so that goes first. Next highest exponent is x squared. And if there's one missing, just skip that. Minus 4x, that's the next one, plus 9. All right, now we've got power of 3, 2, 1, 0. So as long as you're going down the whole way, you're in descending powers. So it's degree 3. We got a 5 on the highest degree term. So leading coefficient equals 5. Your turn number 4. All right, highest power is 5, so start there. 2x to the 5th. Next highest power is 4, so minus 3x to the 4th. And then there's no 3, so we'll skip that, go on to 2, plus 4x squared, and minus 5. All All right, leading coefficient, x to the fifth, gives us the highest order term. Coefficient is 2. So leading coefficient is 2. Now we're going to move on to adding and subtracting polynomials. And this is basically an exercise in combining like terms. Keep in mind the like terms are those with matching variable parts. The variable parts have to be exactly the same. There can be absolutely no difference between the variable parts if you're going to combine like terms. Now this is given with parentheses. The parentheses are actually irrelevant. Really don't make any difference. So we're going to start by combining like terms. Let's find some. 2x squared and x squared. Alright, those variable parts are exactly the same. We have 2 of them here, 1 of them here. Add them together and we got 3x squared. Alright, now the x terms. We got 3 of them here and negative 7 of them here. Add those together, we get minus 4x. Alright, now we can add the constants. Negative 5 plus 10 is 5. So 3x squared minus 4x plus 5. Your turn, number 5. So things are out of order. So you just have to make sure to match up the like terms. We got 4x squared and negative x squared. Subtract those, we get 3x squared. Alright, now we're going to match up the x terms. Negative 2x plus 8x, that's 6x. And then negative 3 plus 10, 13. 3x squared plus 6x plus 13. Now, some polynomials have terms that do not match. So those are not combined with anything. They're just left as is. Alright, so we have an x to the third term here, but we don't have any of them over here, so that's just going to stay 6x to the third. Now we don't have any x squared terms over here, so we're adding 4x squared. That's basically 0 plus 4x squared. Simple. 4x squared there. And now we do have matching x terms, so 2x plus 3x, that's 5x. And then negative 1 minus 2 is negative 3. Your turn, number 6. Let's see what matches here. We got x to the third and x to the third. Those match, so we'll add those together to get 7x to the third. And no x squareds here, but we do have this one, so we're subtracting an x squared. Now x terms, no x terms over here. We do have a 3x here. So keep that. And then we can combine the constants. Negative 1 plus 8 is 7. Now we're going to move to subtraction. We have to be a lot more careful with subtraction, especially when working with these parentheses. Because when we subtract something in parentheses, we have more than one term. We have to subtract each term. And that's where I see a lot of mistakes. Alright, so the biggest mistake I see is people subtracting the first term and then adding the next two. We have to subtract each term. Now, one way you can remind yourself of that is just by rewriting this without the parentheses. 7x squared plus 3x minus 2, and this becomes minus 4x squared minus 3x minus 2. Alright, now we can do like terms. 7x squared minus 4x squared is 3x squared. And this is an optional step. If you can do it without it, that's fine. Now we got 3x minus 3x, that's 0x, so the x's are gone. Negative 2 minus 2 is negative 4. So we get 3x squared minus 4. Your turn, number 7. I'm going to write this one without the parentheses. Keep in mind, subtracting a negative is like adding, so this middle terms can be plus 4x and then minus 7. So basically, just switch the sign on every term inside parentheses. Alright, positive goes to negative, negative positive, positive and negative. Now we can combine like terms. 4x squared minus 3x squared is x squared. Negative 6x plus 4x, that's minus 2x. And 5 minus 7 is minus 2. X squared minus 2x minus 2. Alright, now we're going to look at subtraction with some missing terms. Alright, so we'll start with the x to the third terms. 3x to the third minus 2x to the third, that is x to the third. Now we don't have any x squared term, and here it's helpful to think of that as just being 0. So we have 0 minus negative 3. So that is like plus 3. So we get 3x squared. Next up, we got the x terms, 9 minus 5. So that's plus 4x. And then we have the constants, 7 minus negative 2, that's like 7 plus 2 or 9. So x to the third plus 3x squared plus 4x plus 9. Your turn, number 8. We do not have any x to the fourth terms over here, so we'll just keep this one. 7x to the fourth. And no x to the third terms over here, so it's 0 minus 4x to the third. Minus 4x to the third. Now we'll do the x squared. We got negative 5 minus negative 3, that's the same as negative 5 plus 3. So minus 2x squared. And then the constants, nope, x terms. We have no x's here, but we do have this 4 here, so we're subtracting 4. 0 minus 4 is negative 4. So negative 4x. And then we've got 2 minus negative 8, which is 2 plus 8, or 10. Next up, we're going to add and subtract polynomials using function notation. And this is the main reason for the creation of function notation is so we can create equations with equations without having to write them all out. It's a really nice shorthand. So like previously, if we defined these functions f and g, we can write equations like this. And this may look very strange. You may not have seen something like this before. And it also works for subtraction. You can substitute subtraction in there. Alright, so what does this mean? We have two different functions, f and g. Let's say I'm just going to put some examples up. Let's say I define f of x to be, like we saw before, the doubling function, 2x. And then I'm going to define g of x to be x plus 1. So that's the add 1 function. Whatever we put in, we're just going to add 1 with. Plug in 2, we get 3. Okay. So what this says is that we're going to get the exact same result no matter how we do things, what order we do things in. Over here, what we can do is take some number, plug it into our function. Let's say we want to find f of 3. And we can plug that number in individually into these two functions. And then once we get our answers out, we can then add them together and get some number. And then over here, we're going to do it differently. Here, we're going to add these two functions together first, and then plug the value in. Then plug the 3 in and see what we get. Doesn't matter which way you do it, you're going to get the exact same number. Alright, so this is a way of combining functions together into one new function. We're going to take these two functions, combine them together to make the f plus g function. It's an entirely new function. So let's look at an example of that. Let's say we define f of x to be 3x squared plus 7x minus x. And we'll define g of x to be negative 2x to the third plus 5x squared minus 12. Alright, we are going to find f plus g of x and f minus g of x. Alright, so how do we find f plus g of x? We're going to add these two functions together. We're going to take f of x and add g of x to it. Alright, 3x squared plus negative 2x. Oh, that's x to the third. Okay, so we're going to have negative 2x to the third plus 3x squared. And now we'll add together the x terms, 7x plus 5x, that's 12x. And then we got negative 6 plus negative 12 minus 18. Am I something up here? Oh, I combined these two. Okay, forget this. Pardon me for one sec here. I knew I had something wrong there. That is 7x. I accidentally combined these two. So what do I need here? Yeah, that should be 8. Misread that as 5x. Yeah, can you read my own handwriting? Okay, 2x to the third. 8x. Those got 8x and 7x minus 18. Okay, there we go. So basically what I've done here is add these two functions together, just like we did with the polynomials. So that gives us a new function called f plus g, and there's the equation for it. Now for f minus g, we'll subtract the functions. Alright, so I'm going to take f and subtract g. So we don't have any x to the third term in this one, so that's 0 minus negative 2x to the third, which is positive 2x to the third. Alright, now we'll do the x squared terms. We got 3x squared minus 5x squared, so that's minus 2x squared. Now for the x terms, we got 7 and 0 here, so it's just 7. 7x. And we'll subtract the constants. Negative 6 minus 12 is the same as negative 6 plus 12, so that is 6. So we get 2x to the third minus 2x squared plus 7x plus 6. Your turn, number 9. All right, we're going to find f plus g of x and f minus g of x. So adding them together, all right, we have an x to the third term here, none of them here, so we'll keep that as x to the third. All right, now adding the x squared terms, we got no x squared term here, negative 4x squared here, so negative 4x squared. All right, now the x terms, we can combine those. Negative 3 plus 4 is 1, so that's plus x. And then we got 4 minus 8 minus 4. For f minus g, still going to have x to the third term. All right, now we're taking 0 minus negative 4, so that's going to be positive 4x squared. And now we got negative 3x minus 4x, that's negative 7x. And finally, 4 minus negative 8, that's 4 plus 8, or 12. So there is f plus g of x and f minus g of x. Now, as we saw earlier, we can plug values into the function by plugging a value in for x and then plugging in for every x that we see in the equation. So that's what we're going to do next. So let's say we define f of x to be 18x squared minus 24x, and g of x is 3x. So what we're going to do is we're going to find f plus g at negative 1. So the combined function f plus g evaluated at negative 1. So let's find f of g of x first. Okay, we need the combined function first before we can plug a value into it. So f plus g, we're going to add these two together. So that's 18 x squared and negative 24x plus 3x, that's negative 21x. All right, so there's our combined function f plus g of x. Now we want to find it at negative 1. So f plus g at negative 1, now we'll plug in the negative 1. So that's 18 times negative 1 squared minus 21 times negative 1, which equals, negative 1 squared is 1, so that keeps the 18 positive. And over here, we're going to subtract negative 21, which is the same as 18 plus 21, or 39. All right, now we want to find f minus g of x. So we're going to find the combined function f minus g. All right, f minus g of x. We're starting with f here. And we're going to subtract this one. So 18x squared. Then we do negative 24 minus 3x, so it's negative 27x. All right, so there's our combined function f minus g. Now we're going to plug in 1. So we're going to find f minus g evaluated at x equals 1. So 18 times 1 squared minus 27 times 1. 18 minus 27, and that is negative 9. And that brings us to your turn, number 10. Let's find the combined function. Start with f plus g of x. Got 5x squared, combine the x terms, plus 5x plus 3. All right, now subtract them. That gives us 5x squared. And 12x minus 7x, that's 12x minus negative 7x is 12x plus 7x, so plus 19x. Then you got 2 minus 1, or 1. Now we can plug in the values. We're looking for f plus g of 2. So we're plugging in 2 into this one. That gives us 5 times 2 squared plus 5 times 2 plus 3. All right, evaluating. We got 5 times 4 plus 10 plus 3. That's 20, 33. So we get 33 for f of g at 2. All right, f minus g at negative 2. So we're going to plug in negative 2 for all the x's. All right, that's going to be 20 again. Minus 38 plus 1. And negative 17. So f minus g at negative 2 is negative 17. All right, now we're going back to the introduction. And there's a company called Waking Dream Incorporated. And they sell virtual reality headsets. Now the company is able to project the revenue and come up with an equation. So revenue, or N, is the number of these virtual reality headsets that are sold. And they're selling for $800 each. So 800N is the revenue. For every headset, multiplied by 800, so you get 800 for each one. All right, so there's our revenue. Now the cost associated with creating all these headsets is negative 0.05 n squared plus 300n plus 1,500,000. So a lot of times cost of products are broken up like this, where this would be the fixed cost. This would be like all the equipment they have to buy to start producing them. And then here, it means every headset they make costs them $300. So that might be the raw materials and the labor that goes into producing each one. And then this is commonly included in these calculations. This is something that takes into account that it becomes cheaper to produce headsets the more that you produce. So now we're going to use the profit equation, which is profit equals the revenue minus the cost. All right, paycheck minus bills. So now, this is why function notation is used so often, because instead of having to write out all these equations, we can just write out this, so a lot easier. And if we have to refer to this many times, then we're only writing these symbols instead of all that stuff. All right, now we're going to use the profit equation to find the equation for the profit. All right, so we're going to take our functions and plug them in here and get one equation for the profit equation. All right, so revenue minus cost. So we get 800N minus, you got to put it in parentheses here. So we have to subtract the entire cost function. Right, so then we got this equation here for profit. And now we can tell how much profit the company is projected to make based on how many they sell. So an equation like this is often used to say, okay, how many do we need to sell before we're actually making money? Because if you just sell a few units, you're losing money. And so then they go out and they try to project how many they can sell and decide whether or not they want to make the product. All right, now we want to determine the profit if the company sells 2,500 units or 5,000 units. So N is the number of units we're selling. So let's say we want to figure out how much profit we get from 2,500 units. So we're going to plug in 2,500 into this equation. So that's 0.05 times 2,500 squared plus 500 times 2,500. And calculate all that out, we get 62,500. So just barely breaking even, considering the fact that they put up well over $1 million just to get started. So this would be just about the minimum amount that you want to sell and still make a profit. And then if we go up to 5,000, all of a sudden, and we plug it in just like we did before, and we end up getting 2,250,000. So you can see the profit really ramps up. When you get over that threshold of profitability, every unit you sell after that makes you a lot more profit. All right, now what's the minimum number of units the company must sell to break even? All right, this is looking forward to one of the later chapters in how to solve these types of equations. So breaking even happens when you have exactly zero profit. You're not losing, you're not gaining. And if this is zero, then these have to equal each other. So the break-even point is when revenue exactly equals your costs. So that's what we want here. We want Rn equal to Cn. So that gives us 800, N equals all right, so set those two equations equal to each other. Now, in order to solve this, we have to get everything all to one side of the equation. So we have 0 equals negative 0.05n squared minus 500n plus 1, 0, 0, 0, 0, 0. And now this type of equation is something we're going to learn how to solve later on in the course. So I'm not going to go into the details of this right now. Just going to let you know that n equals 2416 headsets. So there's your break-even point. If they sell 2,416 headsets, they'll break even. And that's why we saw 2,500, just a little bit more, gave them that little bit of profit. All right, everybody, that is it for today. I hope you all have a great day.